This video is for section 5.1. Our objectives in this section are to use the vocabulary of polynomials, determine end behavior, add polynomials, and subtract polynomials. So we're going to start with vocabulary. We're going to define some words, and then we're going to identify the parts of a polynomial based on our definitions. So the first thing that we're going to define is a polynomial. Polynomial is a single term or the sum of two or more terms. Containing variables with whole number exponents. So exponents cannot be negative and they cannot be fractions. Only positive whole numbers. We also have what's called standard form. Which is when a polynomial is written in order from the largest exponent to the smallest. The next thing that we're going to define is the degree of a term. Now, the degree of a term is the exponent if there's only one variable, or the sum of the exponents if there are multiple variables. Degree is a number. And since our exponents are always whole numbers, degree is also always going to be a positive whole number. If we have just a number or a constant, a number with no variables in the term, then the degree of that is 0. Our next definition is coefficient. Coefficient is the number in front in a term, or the number that's multiplied by the variable or variables. We might have used that one already, coefficient, because we saw those in our chapter 3 stuff as well. Coefficient is the number in front. Next, we have the degree of a polynomial. Now, for a term, the degree is the exponent of that term or the sum of the exponents on that term. For a polynomial, the degree is the greatest degree of any term in the polynomial. So when you're looking for the degree of the polynomial, you're not adding the degrees. That's kind of a common misconception here, because you're adding the degrees to get the degree of a term, but for the degree of a polynomial, you're just looking at each term, finding the degree of each, and then looking for the largest one. Next, we have leading term. Leading term is the term with the greatest degree. So this is the term itself. And lastly, we have leading coefficient, which is the coefficient of the leading term. So find the largest exponent. That's going to tell you the degree. Find the leading term. That's going to be where that largest exponent is. And then the leading coefficient is going to be the number in front of that term. So those are my vocabulary words. We're going to look at example 1. It says to determine the coefficient of each term, the degree of each term, degree of the polynomial, the leading term, and the leading coefficient of the polynomial. So we're going to start by going through each term individually and identifying the coefficient of each and the degree of each. So I'm going to start with 7x squared y to the third. The coefficient is the number in front, which is 7. The degree, now here I have two variables, x and y, so I would add the exponents on each. So it's going to be 2 plus 3, which is 5. Next term is negative 17 x to the fourth y squared. If there's a negative sign in front, then that's part of the coefficient of the term. So my coefficient here is negative 17. And my degree, I'm going to add the exponents on the variables. I have 4 plus 2, which is 6. Next term is xy. Now this one doesn't have a number in front, so it would be like an imaginary 1 in front. So my coefficient here is positive 1. Now for my degree, I don't see any exponents, but these are imaginary powers of 1. If I have a variable with no exponent on it, it's like an imaginary exponent of 1. So for my degree, I would add, each of them has a 1. So add the exponents on the variables and you get 2. That one's a little bit tricky. Next term is negative 6y squared. Coefficient is negative 6. And degree, this one only has one variable, which is y. It's y squared, so my degree is 2. And then my last term here is 9 plus 9. Now it doesn't make too much sense to talk about a coefficient when I don't have anything for the number to be in front of, but the book says that if it's just a number by itself or a constant, then the coefficient is just what that number is. So my coefficient here is going to be 9, and when I have a number by itself with no variable like this, the degree of that is 0. So that's going through the coefficient of each term and the degree of each term. My last 3 parts here are the degree of the polynomial, the leading term, and the leading coefficient. So degree of the polynomial, I would look through all of the degrees that I found and find which one is the biggest. So I see I have 5, 6, 2, 2, and 0. So out of those, 6 is the largest. So my degree of the polynomial is 6. My leading term is the term that has 6 for a degree. So looking back up here, 6 for the degree, that's the term negative 17 x to the fourth y squared. So that whole thing is the leading term. The leading coefficient is just the number in front. So the leading coefficient is the number in front in my leading term, so that's going to be minus 17. So that's example 1. Kind of a lot to write out here, but it goes by much faster in the homework because you're just picking out the numbers and typing them in the boxes. So you should do checkpoint problem number 1 in your notes and then move on to the homework for this part of this section.